NASA probe burning up in the atmosphere can sound routine. But this case matters now because it connects us to a larger problem that affects modern life. Van Allen probe came down earlier than expected. And then NASA says the main reason was stronger atmospheric drag during a more active solar cycle. That links the sun's behavior to what happens around Earth in practical ways. Space weather is not only about bright auroras. It can affect satellites, communications, navigation, astronauts, and even power systems on the ground. So this is really a story about how well we understand the space environment close to home. If a long-studied NASA spacecraft returned years ahead of the old forecast, that is a useful reminder. The region around Earth is dynamic. It does not sit still just because our models say it should. The Van Allen probes launched in 2012 as a pair, called Dan B. Their job was to fly through the Van Allen belts, the rings of charged particles trapped by Earth's magnetic field. This is a harsh region. Most spacecraft and crewed missions try to minimize time there because radiation can damage equipment and threaten human health. These probes were built to stay in that environment and measure it over years, not just pass through quickly. According to an ASA, the mission was planned for 2 years but produced nearly 7 years of science before ending in 2019. After the spacecraft ran out of fuel and could no longer keep proper orientation to the sun, the mission helped scientists understand how particles enter and leave the belts. They also found evidence of a temporary third radiation belt during intense solar activity. That matters because the belts are not fixed shells. They change with conditions in space. When the mission ended, scientists estimated that probe would return in 2034, but NASA says those calculations came before the current solar cycle showed how active it would become. In 2024, scientists confirmed that the sun had reached solar maximum, a period tied to stronger space weather. That activity heats and expands Earth's upper atmosphere. Even though the spacecraft was very high up, the atmosphere became thick enough there to create more drag than expected. Over time, that drag pulled the probe lower and lower until reentry came in March 2026 instead of years later. This is the key tension in the story. We often think of orbital decay as a slow and predictable process. It is slow, but it is not perfectly steady. The sun can change the terms. NASA expected most of the spacecraft to burn up, though some components may have survived. And the U.S. Space Force placed the reentry over the Eastern Pacific. The deeper lesson is not just that one spacecraft fell early. It is that the radiation belts are part of a moving system that matters for forecasting risk. NASA says the belts help shield Earth from cosmic radiation, solar storms, and the constant solar wind. But those belts also become a hazard zone for technology. The Van Allen probes gave scientists long-term observations from a place many missions avoid. That made it easier to study how energetic particles build up, move, and disappear. Those patterns are important for estimating how satellites may be affected during strong solar events. They also matter for astronauts who travel beyond the best protected regions near Earth. And there is a ground connection too. NASA notes that space weather can influence communications, navigation, and power grids. So the mission's archived data still has practical value. Better models can help operators prepare for disruptions rather than just react when they happen. There is a useful caution in NASA's update, even with years of data. Forecasting the near-Earth environment still has limits. Probe as return was moved forward because the actual solar cycle turned out more active than earlier estimates used in the reentry model. That does not mean the original analysis was careless. It means the system being modeled changed in a meaningful way. NASA also notes that Probe B is not expected to return before 2030. So the twin mission is not over as a story. The two spacecraft began together, but their endings will differ because orbital paths, drag, and solar conditions do not line up exactly. For viewers of this channel, the clearer takeaway is simple. Space around Earth is infrastructure now. We depend on it, but we do not fully control it. A small NASA update about one probe's reentry becomes a window into a larger question. How do we live with a space environment that remains active, useful, and partly unpredictable?